Hello dear children, in this video we are going to solve the very important numericals. Children, so whenever we are preparing for examinations, obviously we will be thinking what are the important numericals, so how can we cover, what are the topmost numericals in that actually. So in this video we are going to cover top 10 numericals. So let us start without delay. Children, now let us start with the first numerical. So what is given? Two bulbs are rated 60 watt 220 volt, 60 watt 110 volt, means here power ratings are given. Now they are asking us to compare the resistance of the two bulbs. So first what you have to do, just let us write the power rating of the two bulbs first. Children, let us say it is a B1 is the first bulb and here is B2 is the second bulb. So let us write the power ratings first. Now they are asking us to compare the resistance of these two bulbs. First let us write what actually given. Children, according to this data here, so P1 is equal to 60 watt is given, here V1 is equal to 220 volt is given, whereas for a second bulb it is given power is equal to 60 watt and potential difference is given 110 volt. Let dear children, so R1 be the resistance of this bulb B1, whereas R2 is the resistance of the bulb B2. Now they are asking us to compare R1 and R2. So now let us recall the relation between power, potential difference and resistance. Children, we have this relation. R is equal to, it is V square by P. So this is a relation which we are going to use. But dear children, here you have to notice one very important thing. What is that here? Look at here. P1 is 60 watt only, P2 is 60 watt only, which means what? Power remains constant. When power remains constant, dear children, here resistance is directly proportional to the V square. Directly proportional to the V square. So then we can write as R1 by R2 is equal to, it is V1 square by V2 square. Children, what is the V1 value here? 220. What is the V2 value? 110. Let us substitute here. So this can be 220 into 220. Why? Because it is a 220 square it is. Then next one is 110 into 110. Now let us simplify this. It is once, it is twice. It is once, it is a twice. So 2 2s are 4. 1 1s are, it is 1 only. That is R1 by R2 is equal to 4 by 1. So we can write it as a R1 is to R2 is equal to 4 is to 1. So children, this is how we can calculate the ratios of the resistance of the two given bulbs. Here you may get one doubt. Sir, if power is not constant, then how to calculate? It's very simple. When power is not constant, we can write like this only. It is R1 by R2 is equal to V1 square into P2 by, it is V2 square into P1. So children, it's very important. So this is a formula which we use to compare the resistance of the two bulbs when powers are different. But in a given question, it is given that power remains constant. So this is how we can calculate. Just copy it. Now next numerical which we are going to solve from refraction of light at curved surfaces, that is lens. So even you can see the question on the screen also. Here what is given in the question? What position a candle of length 3 centimeters be placed in front of a convex lens so that its image is formed. Its image of length 6 centimeters is formed where on the screen placed at a distance 30 centimeters behind the lens. Now what they are asking? They are asking us to calculate what is the position of the object, and even they are asking us to calculate the focal length of the given lens. First dear children, so in order to solve this numerical, let us make a rough diagram first. Children, here is a convex lens. Okay, so let us say here is a principal axis such that here is a optic center. Okay children, and it is not given, position of the object is not given. Let us say one object is placed here. But dear children, what is given here? Object height is given, that is 3 centimeters. So here object height is 3 centimeters. So the object of 3 centimeters, when it is placed in front of the convex lens, so where let us say the object distance is u, that to be calculated, and its image is going to be formed here somewhere else. One screen will be there. Children, here logically you have to think, As image is formed on the screen means what? It's a real image only. It's a real image only. So where the image is going to be formed? Image is going to be formed, dear children, where exactly 30 centimeters behind the lens. So from here to here it is 30 centimeters. And it is given that the size of the image on the screen is given 6 centimeters. Then what we have to do? Now we have to calculate the object distance. Now let us write the data first actually. What actually given, dear children? Let us take here data. What actually given? So if you can see, object height is given. According to sign convention, dear children, object height is always positive 3 centimeters and image height is given. So image height is always negative. Why? It is real image. For real image height is always negative only. And image distance, as the image is from the right side of the convex lens, so it is taken as a positive, that is 30 centimeters. Now what we have to calculate? We have to calculate the object distance and even focal length also we have to calculate. Children, from the concept of linear magnification, we have this relation V by U is equal to HI by H naught. So HI by H naught. So from this we can write U is equal to H naught, that is the object height by image height into V. Now let us substitute. H naught value is 3 by 6 into, so minus 6, should not forget. And a V value is given, it is a 30. So children, 6 1s are 6 5s are. Now 3 into 5 how much is a? Minus 15. So U is equal to minus 15 centimeters. Children, always object distance is negative only. So here you can cross check whether whatever you got correct or not. So object distance you must get negative only. So according to sign convention, object distance is always negative only. Now what we have to calculate? Now we have to calculate the focal length. So children, from the concept of lens formulae, we know that 1 by f is equal to 1 by v minus 1 by u. Now you can substitute here v value 30 centimeters, u value is minus 15. So this can be 1 by 30 minus 1 by minus 15. Children, here minus of minus can be placed. So here 1 by f is equal to, it is 1 by 30 plus 1 by 15. Children, you can take LCM here, it will be 30. So it is a 1, 15, 2s are. So this will be 3 by 30. 3 by 30 will be how much, dear children? That is 1 by 10 is equal to 1 by f is equal to 1 by 10. So that here f is equal to 10 centimeters. Now we will be solving the numerical based on series and a parallel combination of the circuit. Children, look at here. So the circuit is given like this. It is 5 ohm resistor. So children, this is how actually arrangement setup is given. And one more thing, now they are asking us to calculate the unknown resistance X. But dear children, so across this combination, let us say it is AB. Across this combination AB, the net resistance is given as a 4 ohm. Now the net resistance is given as a 4 ohm. Then they are asking us to calculate the X value. They are asking us to calculate the X value. But dear children, just you forget about the net resistance. So just look at this diagram, dear children. Let us say it is R1. So here is R2. So this can be R3 and this can be R4. So children, here R1 and R2 both are in series. So you are going to get 4 plus 8. So let us write here R1. What we have to do? We have to add the two values. So you will get, it is 4 plus 8 as a 12 ohm. 4 plus 8 as a 12 ohm. Next, dear children, R. So here you will get X plus 5 ohm. X plus 5 ohm. But dear children, this combination and this combination, these two are again in parallel. So I can write the circuit like this, dear children. So now this we got X plus 5 ohm. X plus 5 ohm. So let us say it is A and B only. Now let us think. So now it is a more simplified format it is. Now once again I am saying here the resistance across this A and B is given as a 4 ohm. Let us say across this A and B the resistance is RAB is given 4 ohm. Now dear children, don't you think that these two are in parallel? Now let us apply the concept of parallel combination. So here we have a direct formula. What is that here? Rp is equal to R1 R2 by R1 plus R2. Now let us assume it has a R1, it has a R2. So Rp will be what, dear children? Rab is Rp. So you can write like this: Rab is equal to 12 into x plus 5 by 12 plus x plus 5. But this Rab value is got how much? 4 is given. So let us substitute here 4. Let us substitute here is a 4. Now just what can you do here? With 12 you can multiply. So here 17. Children, here 4 by 1 is equal to 12x plus 60 by x plus 17. Do the cross multiplication. So when you do cross multiplication, you will get 4 into x plus 17 is equal to 12x plus 60. Now let us multiply with the 4. So here you will get 4x plus 68 is equal to 12x plus 60. 12x plus 60. Now let us do here simplification. 12x minus x is equal to 68 minus 60. 68 minus 60. So this can be, sorry, it is a 4x. 4x. So this can be 8x is equal to 8. X is equal to 1 ohm. X is equal to 1 ohm. So this is how we can calculate. Now numerical 4, dear children. So this question is based on apparent depth, real depth and shift. Children, it is given that in a question, here is a beaker in which water is taken such a that the coin is placed here so that its depth is 12 centimeters. It is placed at a depth of 12 centimeters. But dear children, when it is observed from the top, obviously what happens? Due to the refraction, the coin appears to be raised. The coin appears to be raised. So let us say it is raised. Till here it is raised. So let us say it is a image. It is image of the coin. It is image of the coin. Means this what actually? Apparent depth. It is apparent depth. Now this will be what, dear children? This is shift. This is shift. Now in a question, they are asking us to calculate at what height the coin appears to be raised. At what height the coin appears to be raised, which means what? They are asking us to calculate the shift but not apparent depth. Don't get confused. Appears to be raised. Children, appears to be means apparent depth. Here it is asked appears to be raised. So we have to calculate the shift. So dear children, here how shift is related to the real depth here. Children, we have this formula. Shift is equal to real depth into 1 minus 1 by mu. 1 minus 1 by mu. So according to the question, dear children, real depth is given as 12 centimeters, whereas refractive index of the water is given as 4 by 3. Now you substitute these values in this, then you will get it is 12 into 1 minus 1 by 4 by 3. So this can be 12 into 1 minus 3 by 4. Here you can take LCM, dear children. What you will get here? 4 minus 3 by 4. So this will be 12 into 1 by 4. 4 ones are here, 4 3s are. So this is how much? 3 centimeters is the shift. 3 centimeters is the shift. So children, this is what actually they asked us to calculate. So here when the coin is observed, so it appears to be raised by 3 centimeters. But for suppose, dear children, the same concept, if they will ask us to calculate apparent depth, if they will ask us to calculate, how can we calculate? Simple here, that is real depth is equal to apparent depth plus shift. Apparent depth plus shift. So from this, apparent depth is equal to real depth minus shift. Real depth minus shift. So it can be 12 minus 3. So this is 9 centimeters. 9 centimeters. So this is how we can solve and we can find out even shift, even we can find out apparent depth also. Just copy it. So here is question number 5 is based on law of refraction, especially it is based on Snell's law. What is Snell's law, dear children? The ratio of sine of angle of incidence to the sine of angle of refraction is always constant. That constant only we can call it as a refractive index. Children, here it is given that, children, look at here, this angle is given 30 degrees and children here it is given as 45 degrees. This picture is given. So let us say the light ray is moving from air to some liquid. Air to some liquid is moving. Now first they are asking us to calculate. They are asking us to calculate the angle of incidence. Angle of incidence. Children, by seeing this, many students will take 30 as angle of incidence, but it is wrong. What is angle of incidence, children? The angle between normal and incident light ray is angle of incidence. Is angle of incidence. Dear children, this total is 90. Okay, from this 90, 30 is gone. So this will be how much? 90 minus 30. 90 minus 30. So here angle of incidence is equal to 90 minus 30. So you will get it as a 60 degrees. It is the angle of incidence. And what is the angle of refraction? The angle between normal drawn and refracted light ray is called angle of refraction. Anyhow, directly it is given as a 45 degrees it is. So angle of refraction is 45 degrees. Now dear children, they are asking us to calculate the refractive index of this liquid in which light ray is getting refracted. So here we have to use the concept of Snell's law. Children, according to Snell's law, the refractive index of liquid with respect to air is equal to sin I by sin R. Sin I by sin R. Anyhow, the refractive index of air is 1 only, so we don't take A here. Directly we can take a mu L. So here sin value you can, I value you can substitute here. It is sin 60 by it is sin 45. Dear children, sin 60 is equal to how much? Root 3 by 2. It is root 3 by 2, whereas sin 45 is equal to 1 by root 2. 1 by root 2. Now if you can simplify this, dear children, you will get it as a root 3 by 2 into root 2 by 1. Dear children, here this 2 can be written as root 2 into root 2. So like this we can write. So it is root 3 into root 2 by, it is root 2 into root 2. So one root 2, another root 2 gets cancelled. So the answer can be, it is root 3 by 2, or if you can simplify more, you may get it is 1.4 something. 1.4 something you get. So this is refractive index of the liquid. So children, this is how we can calculate the refractive index when angle of incidence and angle of refraction are given. I mean what? Angle of incidence is given indirectly, not directly. So first we have to calculate the angle of incidence, then we can apply Snell's law. Okay children. This now we will do the numerical based on resistance. Children, it's very important. So children, here we have a relation how resistance is like a depending on length means proportional. R is proportional. But dear children, when volume remains constant, that is a stretching case, R is proportional to L square. It's very important. That we are going to solve now. Children, it is given that according to the numerical, it is given that here is a wire of length 10 centimeters and it has resistance 3 ohm. Resistance 3 ohm. Now it is stretched. It is stretched such a way that its length became 3 times. That is, new length is 30 centimeters. Children, same one it is. Try to understand. It is same wire only. Just it is stretched. Just it is stretched so that its length 10 centimeter became 30 centimeters. Now, what is the resistance of this wire they are saying? The wire which is stretched. For that wire, we have to calculate the resistance. Children, let us say it is a R1. So that it will be L1 and this will be L2. Now we need to calculate the R2. It is R2. Dear children, so when the wire is stretched, then what happens? Its length increases, area of cross section decreases. But dear children, volume remains constant. Volume remains constant. So in that case, especially dear children, stretching case, so we have this relation. R is proportional to the L square. Children, this is only in the case of stretching case. Only in the. So how do we get this? Children, we know this formula. R is equal to rho into L by A. Rho into L by A. So this formula you multiply with L and divide with L. L into L will be L square. So here R is equal to, it is rho into L square by, children, area of cross section into length will be the volume. So it is the volume. Dear children, so as the same wire is stretched, means material is same. So rho is constant and its volume is constant. When specific resistance and volume remains constant, R is proportional to L square. So this is how actually we got from this relation. So this can be written as R1 by R2 is equal to L1 square by, it is L2 square. Now you substitute the values. So R1 is given, it is a 3 by 10 is equal to, sorry, R1 is given, R2 to be calculated, R2 is not given. So L1 is given 10 square, L2 is 30 square. This is 100 by 900. So zeros cancel. So this is 3 by R2 is equal to 1 by 9. Just do the cross multiplication. You will get R2 is equal to 3 9s are how much? It is a 27 ohm. So children, this is how we can calculate the resistance of the wire when it is stretched. Stretching case, children, stretching case only we have to use R is proportional to L square. Just copy it. So children, now we are going to do the numerical based moment of force. Children, moment of force is a vector quantity. So what is the moment of force formula? Let us recall once. Mathematically, moment of force is equal to force into perpendicular distance. So in this question, what is given? So it is given that a nut is opened by a wrench of length 10 centimeters, it is given. That's, sorry, 20 centimeters is given. Now a least force is required is a 5 Newton, they are saying. Now what is the moment of force needed to open the nut, turn the nut? You have to open means what? We have to turn the nut. So we have to calculate the moment of force. Children, it is given force is equal to 5 Newton, but whereas the length is taken as here perpendicular distance is given 20 centimeters. But dear children, so this question seems to be very simple, but here only many children will do wrong with excitement, with over excitement they will do wrong. Why? Here force is given Newton, that is SI units, perpendicular distance is given centimeters, that to be converted into meters. How? 20 centimeters is equal to 20 by 100, that is 0.2 meters. Now you get it, that is tau is equal to 5 into 0.2. So as 5 into 0.2 is 1. So the answer is 1 Newton meter. So here 1 Newton meter is the moment of force which is required to turn the nut with a wrench of length 20 centimeters if you can apply the force of 5 Newton. So this is how we can calculate. Here only you should be very careful. Right? Now one more very interesting thing is that already we discussed in the previous class about kinetic energy, and we know that kinetic energy depends on mass and velocity. But okay, in this question, let us suppose two bodies of same mass. Here is one body, here is one more body of same mass, but first body is moving with a velocity v and the second body is moving with a velocity 2v. Then how can you find the ratio of the kinetic energy? Children, do you think that kinetic energy is same in both cases? Of course no. Why? Because they are different velocities. So first let us recall the kinetic energy formula. Children, kinetic energy is equal to half mv square. But children, here half m remains constant. So kinetic energy is directly proportional to the v square. From this we can write kinetic energy of first body, let us say the first body, it is the second body, by kinetic energy of second body is equal to velocity square of the first body to the velocity square of the second body. Children, this can be v1, this you can take as a v2. Now you can substitute in this. In the place of v1 square, it is v square only. But when you are substituting vt value, you must be very careful. Why? Some students they will write like this, 2v square they will write. But children, this square is for whole. This is very important. So this you can write 2v whole square it is. So here ke1 by ke2 is equal to v square by it is 4v square. So v square gets cancelled. This will be 1 by 4. So dear children, so ke1 by ke2 is equal to, or else you can write in the form of ratio, Ke1 is to Ke2 is equal to 1 is to 4. So children, here what you can notice here, when velocity is doubled, the kinetic energy is increased by 4 times. Right? It's very important, children. Why? Because kinetic energy is proportional to the square of the velocity. As second body is moving with the double the velocity than the first body, so it possesses kinetic energy 4 times greater than that of the first one. Now we will do one more very important numerical relation. It's based on the echo concept. But here thing is that directly here in this question the time period is not given, dear children. So what actually the question what actually given is that, look at here. Children, let us see, here is a cliff, okay, and here is person is standing. A person is standing. So let us say that in his hand one gun is there. One gun is there. So what happens when he fires that gun? Obviously after some time he can hear the echo. For suppose the speed of the sound is 340 meter per second and he is standing at a distance d from the wall or cliff. But the children, the thing is that the time for echo is not given and they are asking us to calculate the distance between the cliff and the person. But here one clue is given. At the same time, dear children, at the same time the person is holding a simple pendulum. A person is holding the simple pendulum and its frequency is given as a 2 vibrations per second. Children, let us recall one's concept of simple pendulum. So here is vibrating. So for this the frequency is given, dear children, 2 hertz. As frequency is given, dear children, 2 hertz, can't we calculate time period? Of course we can calculate the time period. So what a time period of this pendulum? Time period is equal to 1 by frequency, that is 1 by 2. So it will be 0.5 seconds. So 0.5 seconds is a time period. But can we take 0.5 as a time here? No. Why? Because the person, when he fires a gun, he can hear the sound. Till that time, what happened? The simple pendulum completed 10 oscillations. So which means what? For one oscillation, it is taking 0.5 seconds. Try to understand. For one oscillation, 0.5 seconds, 0.5 seconds. Then for 10 oscillations, how much time does it take? So for 10 oscillations, 10 into 0.5, 10 into 0.5, it is 5 seconds. So children, here 5 seconds is a time taken in which the person can hear the echo. So this is how actually we can calculate the time. So here now we got the time. Time to go, sound is going here and is coming here. For that, the time taken is how much, children? 5 seconds. It is given 5 seconds. Now let us recall the formula of echo. So children, so here V is equal to, it is 2d by t. 2d by t. So let us say it is small t. Nothing is wrong. It is a small t. Now what we have to calculate? D value we have to calculate. So here d is equal to, it is V into t by 2. So V value is how much is given? 340. And time is given 5. Time is given in the sense we calculated. We directly, the value is not given. We calculated. And this is t. T is what is 2. So 2 ones are 2 170. So 170 into 5 is how much, dear children? It is 0. Dear children, and this is the last question in this session. So this question is based on calorimetry. This question is based on calorimetry. Here what is given, dear children? In this question it is given that now they are asking us to calculate the heat supplied. So children, how much amount of heat is required in order to raise the temperature of 100 grams of copper from 20 degrees Celsius to 70 degrees Celsius. And here one more, the important information is given that specific heat capacity of copper is given. So let us write the data first, dear children. What is given here? Mass is given 100 grams or degree Celsius, anything is okay. Why? Because the rise in temperature in a Kelvin scale is equal to the rise in temperature in Celsius scale. Now we have to calculate what Q value. They are asking us to calculate the Q value. But dear children, here one important thing we have to notice. What? Specific capacity value is given in kg, but the mass is given in grams. So we have to convert grams into kg. So 100 grams is equal to 0.1 kg. 0.1 kg. Children, now we have this relation. Q is equal to mc delta t. Q is equal to mc delta t. Here m is equal to 0.1, c is 390 and it is 50 joules. So children, this is how we can calculate the amount of heat required when mass, change in temperature and specific capacity is given. But you must be very careful whether mass and what is specific capacity. You have to compare that mass units whether it is given same or not. If not, we have to convert. So children, these are the top 10 numericals which are very important, and we have covered from almost all chapter. And in next video, dear children, and we are going to just discuss a part 2. It is a part 1 of the top 10 numericals, and we are going to do next part 2 also there. In that we are going to cover more methods from a different chapters. Thank you so much. All the very best.